So this is section 8.5. Proving triangles are similar for geometry class. So what I've got going on here is I have a couple of pictures. Here are 4 pictures of the Unisphere. It's called the Unisphere. It's a giant structure. Okay, you can see a couple of pictures. There's a guy on a skateboard in the top left, jumping off some stairs. There's a faraway picture in the top right. We've got a guy standing there in the bottom left, looking at some fountains. And then there's a faraway picture down the the bottom right. So I have a multiple choice question. It's a free guess. So where do you think this is? Is this in Florida, New York, Seattle, New York? Okay, so yeah, the Unisphere is in New York, and it's in this beautiful park. And I'll tell you the name in just a second, right? But here we go. The next question I have from you, okay? Based on the photos, how tall do you think it looks? Based on the photos in the pictures, how tall do you think it looks? Write down your guess somewhere on the left-hand side of the picture. Based on the photos that you see here, the guy with the skateboard, the guy standing here, this over here with the mountains coming up. Based on the photos, write it down. Let's guess. That's the picture. Is there a car? Anywhere here? But these are flagpoles, and those are about 30 feet, as we came up with yesterday. So maybe you can infer from there. Yeah. Okay, talk to your neighbor, see what they have. Talk to your neighbor, see what they have. And we're going for feet here. We're going for feet. You guys can play too if you want that. Right, guys. This is in New York. Is it right there? Yeah, call it. Okay. All right. Let's get our ranges here. Give me a guess. Brett, give me a guess. 84. Anybody go? Let's get our height. Anybody go higher than 84? Yeah, what'd you go? 150. Anybody go higher than 150? Yeah, what'd you get? 152. Anybody go higher than 152? What'd you go? 320. Anybody go higher than 320? Okay, there's our height. 320. Okay, let's get our low range. What's our lowest range? I heard 84. Anybody go lower than 84? Yeah. 12 feet. Really? 12? 12? Alright. Did it go lower than 12? So I have 12 to 320. Do we think our answer is somewhere in there? Okay, anybody want to adjust our range? Anybody want to adjust our range? Down to 200. Okay, 200, so 12 to 200. Anybody want to bring up the bottom end? Yeah. 90, okay? 90 to 200. Anybody want to bring that up? Yeah. 91. Anybody want to bring that up? Okay, alright, so 91 to 92. Okay, well, turns out we're gonna use a mirror to figure it out. So what was it? What was our guesses? It was 92 feet to 100 and what was it? 50? Oh, 200. Sorry. So 200 feet. Okay. Do we think that based on the photos? That's right. Okay, based on the photos. Okay. So let me give you some information then about what this guy over here is doing. It's kind of hard to see. So let's see if I can make this a little bigger for you guys. I have the answer right over there in the wiki, so we'll get there in just a second. Okay, so here, see this guy standing here? He has a little tiny pocket mirror. Any girls carry it around? For like makeup? My wife is the only one that carries this around. They have mirrors on the phone? Yeah. Alright, well, nobody? Am I crazy? I'm already that old? Wow, okay. Alright, so what this guy's doing, right? He's standing here, okay, and I'm going to show you a side view over here on the left, or on the right-hand side here. Okay, he's standing here, and at the base, he's got his girlfriend or his wife's mirror. And what he's doing, he's looking at the mirror, and he's standing a certain distance away until he can see the top of the Unisphere. So let me give you a side view as to what he's really doing, okay? So here's the side view, and here's my best drawing of a dude standing over here. It's pretty good, huh? And then here's my best drawing of the Unisphere over there. It's not very good, but that's okay. So what he's got is he's got a mirror on the ground here. He's looking at the mirror until he can see the very tip top of the Unisphere. You guys get the picture now? Okay, so what information will we need in order to really figure this out? What do we need? Someone see something in here? Yeah. Height. His height. How tall is he? That's a great thing that we need, right? Turns out that this gentleman is 5.6 feet tall. What else would we need? Somebody else. What else would we need? Yeah. How far he is from the mirror. That's great. Yeah. How far would he have to be from the mirror? Turns out he is standing 4 feet from the mirror. What else would we need? Somebody else. Somebody else. Somebody else. Yeah. How far away the mirror is from the center of the sphere. It turns out he's 100. That's 100 feet away. Okay. What are we looking for? The height. Okay. With a partner, elbow buddy, see if you can figure it out. Go. With a partner or elbow buddy, see if you can figure out how tall is the Unisphere, and then we'll look up the wiki and see if we're right. Wait, they want to know how tall this thing is. They want to know how tall it is. Okay. We'll text you. Yeah, that's right. We'll text you the answer. Once we figure it out, we'll text you the answer. All right, you got calculators? Everybody got a calculator? We have that in here? All right, how tall is this thing? You got something? 10 feet off. That's what you have, huh? Okay. Alright then. No, that was a different group of people. We are just in model school, man. People want to know what's going on. You know what I mean? We want to know what's going on. You got an answer? What are you doing? John, she doesn't have an answer. Turn around and talk about. Yeah, an answer. Anybody else? Go have an answer? You, George, share your answer with them and help them out. Let's get some learning on here.
I got 26.
It's a long part. We don't need this part. There. Side, angle, side. Side, angle, side. Similarity. Huh? Okay, thanks. Let's do AB. And let's compare that to what's the shortest side of my second triangle there? ED, right? Okay, so, or DE, right? Okay. And that's equal to 6 divided by 4. You guys agree with that? Which is then equal to 3/2. Okay, good. So I'm comparing the first two. Okay, great. Let's go to the longest side. I'm comparing the first two right now. What's the longest side of the first triangle? AC, so I'll go blue here. And so I got AC divided by which one? DF. And that's equal to 12 divided by 8, which is equal to 3/2. Isn't that correct? 3/2, right? Good. And then let's check the remaining sides of the two triangles, in the first two triangles. So what's the remaining side I have? BC. Tell me what it is. BC over what? EF. Which is equal to, what's the length of BC? 9 divided by what? 6. Does that equal to 3/2? Okay, so because each of these is equal to 3/2, we now know that the first triangle and the second triangle are similar. Okay, what's the longest side in the middle triangle? Okay, so if you compared FD to what? To GJ, that equals 8 divided by 14, which is equal to, what do you get, 4/7, is that right? Okay, then what'd you do? Okay, what's the shorter side then? ED, yeah, if you compare ED to what? To GH, what does that give you? That gives you 4/6, which is equal to 2/3, is that right? So now 2/3 and 4/7, are those the same? No, so what did that tell you? It tells you that the two last triangles are not similar. Okay? What about the the beginning and the end triangle? Can anybody do that one? No. Are they or are they not? Can we compare them? Let's see here. 6/6, is that the same thing as 12/14? It sure is, and so those are not similar. So the only ones that were similar were the first two. You guys fast. All right, we did approve, and